Okay, so what I want to go over now is electronegativity. So electronegativity is symbolized by the Greek letter chi. So this is chi. And it is just a measure of the ability of an atom in a molecule to attract electrons to itself. This number does not have a unit. The larger the electronegativity value is, the better able an atom can attract electrons to itself. So the trend here is that, again, the opposite of a radius trend. So if we look at our periodic table, remember the radius increases going down a group. Ionization energy and electronegativity will increase in the opposite direction. Same thing going across the period. It will increase in the opposite direction to the increase in radius. So what we see is that if we have fewer energy levels, a nucleus can attract electrons better because there's less shielding, there's less electrons in the way of the ability of the nucleus to attract other electrons. So electronegativity increases going up a group of elements. Going across a period from left to right, we have more protons in the nucleus. This allows the atom to better attract electrons to itself. So electronegativity increases going to the right in a period. What we also see is noble gases, because they don't form compounds, do not have electronegativities listed. That's because electronegativity can only be determined for elements which do form compounds. So if we look at our table of electronegativity, you will see there are no electronegativity values for noble gases. So this is only measured for elements that form compounds. So noble gases, there's no electronegativity values for noble gases. Okay, so I want to practice this, how to look at this trend with some problems. So I'm going to bring up some problems, and I want you to get out a piece of paper, have your periodic table out so you can practice also. Okay, so we have here some different elements, and I want you to pause the screencast. Think about the pattern, the trend that you should be seeing, make predictions, and then we're going to go over the answers. Okay, so hopefully you wrote down answers for all of those. So if we look at the first three, those are all on the same period. We look at lithium, carbon, and nitrogen. Nitrogen of those three is the furthest to the right, so it should have the largest value for electronegativity. So the pattern should be the same. It should be lithium, carbon, and nitrogen, with nitrogen having the highest, lithium the lowest. And again, it helps to write this little table here so you can remember the trend. We look at carbon, oxygen, and neon. Again, carbon, oxygen, neon are in the same period. Neon, however, this time is a noble gas that will not have an electronegativity value listed. So we only pay attention to carbon and oxygen. Carbon will have the lower one. Oxygen will have the higher one. We look at silicon, phosphorus, and oxygen. Oxygen is in a higher period on the periodic table. It's in period 2, so I'm going to write that down. And phosphorus is in period 3, so is silicon. Oxygen will have the highest of the three since it only has 2 energy levels. Then we have to figure out between silicon and phosphorus. Phosphorus has more protons in the nucleus than silicon, so it will have the next highest. Silicon has the fewest protons in the nucleus, so it'll be the lowest. We look at the next one, potassium, magnesium, phosphorus. Potassium has 4 energy levels. Magnesium has 3. Phosphorus has 3. Okay, so potassium will have to be the lowest since it has the most energy levels. And then we have to compare magnesium and phosphorus. Magnesium has fewer protons than phosphorus in its nucleus, so phosphorus will have the greatest electronegativity, and magnesium will have the one in the middle. Look at the last one, sulfur, fluorine, and helium. Helium, again, is a noble gas. It will not have electronegativity values listed. So then we just have to compare sulfur and fluorine. Fluorine has 2 energy levels. Sulfur has 3. Fluorine will have the greater electronegativity. Sulfur will have the lower electronegativity. Okay, so just continue practicing, figuring out your electronegativity values for your homework problems, and email me if you have any questions.